Hey guys, welcome to the feed. It's great to have you. And to start it off, me as a Russian guy, I know the word babushka, I know the word babachka, and I can see that Babashka has a logo. So, Michiel, what inspired you to give such a name to your library?
That's a good question. So I wanted to have Bash in the name because Babashka is a Clojure dialect which you can use instead of Bash for scripting. And then I thought of the name, and then I needed to have some silly logo. And I thought, well, it is close to babushka, and this means granny in Russian, I believe. And so this is how it how it came about.
Yeah, fun. It's very nice to see this logo and to kind of have a familiar vibes. Nice. So, Nikolai, did you get any chance to use Babashka yet?
Yes, I've tried Babashka, but I'm definitely a user of Clojure Condor. Huh. And I want to thank from the Clojure community, Michiel, for this amazing tooling around Clojure. We all use it. Thank you for creating and supporting it. Yeah.
Yeah, it's amazing. I do have to admit that I'm not an experienced or seasoned Clojure developer, but I really enjoy the idea of functional programming, so it would be cool to use it. So how does the community, like this Clojurians community, does it also have like dedicated Clojure meetups or worldwide conferences or stuff like this?
Are you asking me? Or
okay, let's go with Nikolai first.
Yeah, definitely. We have a lot of communities, local communities, the global communities. We have a lot of meetups. You can just go to YouTube and enter Clojure meetup. You will find a lot of meetups about the Clojure. I don't know what is our major conference. Maybe Michiel know this. So we have few Clojure conferences. Yes.
Yeah. I think the major one is the Clojure Conch, I think, in the United States.
Yeah.
I by the way, I have one issue with my presentation because I want to have it full screen, but I don't want to see the preview because then it overlaps your faces, let's say. So does any one of you know how I can play the presentation without the presenter display? Perhaps.
Aren't there like separate buttons, show with presenter view or just start slideshow versus start slideshow with presenter, you know?
Play slideshow in window. Yeah, this is it. Okay.
Perfect. Then I guess we can just get to it then. Please show it to us.
Sorry, yeah. Well, I didn't mean to we can still answer the question that you asked. So the meetups, so I think there are a lot of meetups. We have, in the Netherlands, we have a meetup and they organize a conference each year as well. The Amsterdam, it used to be called the Amsterdam meetup. Can you still see me or?
Yep.
Okay, because Nikolai is frozen now for me, but okay. And so I also heard you have a Russian Clojure meetup.
Yeah, we have a Telegram group, so everybody who interested in Clojure can join it. This is Russian group. And we had even the Russian conference. Clojure, it was the first conference. So hope that it will repeat again. And and we have a lot of meetups, and during the COVID time, it's easy to organize meetup. Just start the Zoom and throw the link.
Yeah.
Just search for Clojure Russia in YouTube. You will find these presentations.
Nice. Perhaps I will check some out. Thank you. All right, let's go.
Okay. So I will start my presentation. This presentation is about Babashka, which is a native Clojure interpreter. And this is a Java conference, so not everybody might know what Clojure is. And so I will give a very short introduction Clojure is a Lisp which lives on the JVM. Just to give an idea, so there is a command line tool called CLJ, and this starts a JVM, and then you can say system get property user there. So we are on the JVM. You can see that here. But this is a Lisp, and Lisp is an interactive language, which means you develop programs using a REPL. So, and a REPL, in a REPL, you can define functions like this. I'm defining a function foo, and here I'm calling the function foo. So this is how you can build up programs in the REPL. So we don't usually restart the JVM when you write a program. So there is a website called Clojure.org where you can find more information about what Clojure is. But it is another JVM language, basically, like Java and Scala and Kotlin. We have also Clojure. And it's a dynamically typed language, which is very flexible, but it also emphasizes functional programming. So the data types in Clojure are immutable. So it really guides you into the direction of functional programming. So it has a couple of properties that really makes it unique compared to other languages that are statically typed and have more like a compile, a write, compile, run cycle, where Clojure is interactive. So that is Clojure. And so what is then Babashka? So why do we need another thing that is not the official Clojure, let's say? So the problem that Babashka solves is if you start Clojure, so you can execute an expression like this, then it takes 1.2 seconds on my machine. Let's see, yeah. So that is not so nice for scripts, because if you execute bash scripts, this you expect this to be very fast. Like for example, Python is very fast. I think you can do it like this in Python. I'm not entirely sure how, maybe like this. Yeah, okay. So print 1 + 1. So you see this is very fast. It's only 32 milliseconds. But the equivalent in Clojure is +1 like this. And this takes 1.2 seconds. So this is where Babashka comes in. It tries to provide a Clojure environment where you can use it for scripting with very fast startup. Oh, I get a message, sorry. Laptop, it was shaking. Oh, oh, sorry. I will try to not move my desk too much. And it has a couple of properties that make it nicer for scripting. That is basically the idea for Babashka.
Yeah, Michel, can I interrupt you slightly?
Sure, of course, yeah.
So, because this probably the most of auditory is new to Clojure, can you make some motivation to learn the Clojure, why Clojure, and probably tell your story how you get to the Clojure and why you are using Clojure? So it just advertises slightly. Just another dynamic language. It's not enough.
Yeah. So personally, I like what I like about Clojure is that it's more compact. I'm not sharing my screen anymore. Yeah. Okay. Yeah. Okay. I'm resharing my screen now. Sorry. Okay. Yeah. So what I like about Clojure is that it's compact. So you can define functions, and you can run the functions without all the ceremony of public static void main stuff in Java. So you don't have to define any classes or whatever to do what you want. Clojure really gets out of your way. You can focus on your problems instead of focusing on the programming language itself. That is basically what I like about Clojure. There is also yesterday someone asked on Twitter, why do you like Clojure for scripts? So this is more focused on scripts, and there were a couple of nice answers, and one answer that particularly I liked was that a Clojure is a symbiote that attaches to a host platform. So Clojure deliberately marries to a certain platform like the JVM, so you can use all the tools from the ecosystem, all the libraries from the JVM, but also we have Clojure script, which does the equivalent for JavaScript. So you can write Clojure for the front end as well. So you can use all the JavaScript libraries using the same language. So you only learn the language once, and then you can use it everywhere. You can use it on the back end to do JVM programming, but you can also use it to create front end applications. And now with Babashka, we can also use it for scripting. I hope this answers your question a little bit.
And what is your personal story with Clojure?
I think we can back to the talk. I think it's the quality is okay now. And then the personal story we can leave for that.
Yeah, maybe we can do the personal story in the Q&A session. So, but I want to also tell you in this talk how I made Babashka and what you can do with it. So Babashka is made using a technology called GraalVM. You might have heard of it. It is a JVM implementation by Oracle, so it's an official JVM implementation that supports compiling programs to native. And so this has the added benefit that your JVM programs can have instant startup. So one tool that I made using this technology was Sail-Giocondo, which is a linter for Clojure. So if I open my editor, so this is an editor, and I type some expression. So here I call the plus function, but I call it with a number, but also with a keyword, which is not valid. So when I'm on this invalid argument, the linter says, I expected a number, but I received a keyword. So this is what Sail-Giocondo does for you. So it's a linter and a static analyzer for a Clojure compiled with GraalVM. So you have native, so you have very fast startup. So you can see it like this. So it's instantaneous. So you can hook it up to your editor. So you get linting errors like this. So this is the first tool that I made with GraalVM. I also made other programs with other command line tools with GraalVM. One of them is Jet. It's like JQ, but for Clojure, let's say. But one limitation of using GraalVM and Clojure is that you cannot use dynamic evaluation. So you cannot dynamically define functions or things like this. And the reason for this is that Clojure is a bytecode compiler. So every program you write in Clojure emits bytecode, and this bytecode is then dynamically loaded onto the class loader, and then you can use it. But this is not possible with GraalVM. But because with GraalVM, your binaries are a closed world, so you cannot dynamically add things to this. So this is why, so Babashka, you cannot really use the standard Clojure compiler for this. And this is why I made an interpreter for Clojure, which is compatible with GraalVM. And this is basically what Babashka is. So you can evaluate expressions in very fast startup time. So it's a native Clojure scripting tool. It's only a single binary. You don't need a JVM to run it. So you just download the binary and that's it. So if I give a demo of that, you can say +1 to 3. But you can also do Java-like things. So you can say get property user dir. This. And that still works because Babashka also supports a selection of JVM classes. So you can say Java IO file. Let's say this is a constructor that we're calling here. So this is a file object. So it is a Clojure interpreter, but it supports interop also with Java classes. And you can use all of this for scripting and have fast startup. So that's basically the added benefit of Babashka compared to the JVM Closure. To give an overview, I already showed that if you use the JVM Closure for scripting, it doesn't have such a good startup, but Babashka improves this. But the trade-off is that Clojure is compiled using a very efficient bytecode compiler, but Babashka is interpreted. So if you have code that should really be performant and the startup does not matter a lot, then it's better to use still Clojure. But for small scripts, like in the area of build scripts, then Babashka is more suited. And there are a couple of other alternatives which are based on either JavaScript or Go, which also provide scripting environments. Just an example script. So this is a pretty sophisticated script already. So you can have a shebang. So you can invoke the script just by name, and then it will invoke Babashka for you. The binary is called BB, by the way. And here I'm using interop with Java time to find out what time it is in Los Angeles at the moment, because that is where some of my colleagues are. Let's see. I've put this script on my path. So it's now 10 before 3 o'clock in Los Angeles. So, and I just put this script on my path. So you can see it here. It's just a Babashka script. And it's just, I can make tiny utilities now in Clojure for that I can use on the command line. But what is cool is if you use a standard language like Clojure, and which is based on Java standard libraries, then it also works on Windows. So you write a script once and you can run it everywhere, just like Java. So the script is cross-platform, which is nice. So you can even use it on the Windows environments. Any questions so far?
Can you show examples? How do you use Babashka in your real life? On your
yeah. I can maybe, I can show an example from work maybe. So I work for a company called Dr. Evidence, and we use Babashka. Let's see. So we use Babashka to, this is a pretty big script, but we are generating dependency files for Clojure using Babashka. So if we have a standard list of dependencies that we always want to preserve the same version in all our projects, and we use that, we enforce that using a Babashka script. I won't go into the details, but this is one of the ways that we use Babashka. But usually the place of Babashka is in a larger Clojure project where you have a backend and a front end and some build scripts. And the build scripts you can then use in the same language as all the rest. So you can have almost 100% Clojure in your project. So there is one project called Rewrite CLJ, which uses a lot of Babashka scripts. Let's see. So you can see it here. All these scripts in the script directory are all Babashka scripts. So it's all used to trigger commands in CI or during development, let's say. So here, this is a lint script. It invokes, it invokes CLJ Condo on the JVM, and it does some scripting around it to check the exit code and stuff like this. So you can see a lot of examples in this project as well. I use it in almost all of my open source projects to do build scripting, let's say. Babashka comes with a lot of built-in namespaces. So it comes with the standard Clojure namespaces. This is book.babashka.org, by the way, so you can find all this information over here. But it also has external libraries from outside of the Clojure standard library. For example, Cheshire, which is a JSON library to deal with JSON. It has an XML library. It has an ARC command line argument parsing library, a YAML library, a web server, some library to produce HTML, etc. So you can use it for a lot of purposes as well. And all these built-in namespaces are all started instantaneously. One example of using the web server is, there is an examples directory in the Babashka repo. So you can see a lot of examples here. And one example is the file server. And there we re-implement that, let's say, the Python -m HTTP server replacement with a couple of more options. So it uses the built-in web server and it produces HTML. So I can, and it has some logic around MIME types. So it's just a Babashka script. So I can, on my system, this script, it's called HTTP server.clj. So now I started it, and you can see that it's pretty much instantaneous. So you can start this from anywhere on your system. So when I go to the temp directory, I started here. You can see I'm now in my temp directory and just navigate through this through these directories. Let's see, do I have a directory or I don't know. But this is how this works. So that's the HTTP server directory. There is also something called pods. So Babashka is not able to execute any library because of limitations. It doesn't include all of the JVM's classes. So some libraries it doesn't. It cannot run from source, but it can run a lot of libraries from source. So we have a list here from libraries from the ecosystem that you can run from source. So you can say in your script, you say, I want to load dependencies, so I require this namespace. And then you say, well, here, this library is here. This is the organization and the name, and this is the version. and then it uses Maven in the background, or really the Clojure build tooling in the background to pull this library, and then it interprets this library. Instead of using the JVM compiler, it interprets this library, and then you can use this library from the ecosystem. So yeah, I can maybe show this. Let's see. So this is a library to convert different casing styles. So we try to convert this symbol to camel case, and so this is what it should return. So when I go to the command line and I say bb camel, the first time it takes a while because it has to resolve these dependencies, but the next time it's almost instantaneous, like you can see here. So this is how you can use libraries. But to deal with limitations, we also support something called pods, which are other binaries that Babashka can talk to. It almost behaves like an RPC-like system. So it downloads another binary. In this case, it's called a bootleg. And then it can call functions from this binary in an RPC-like fashion. So here so this pod is registered. We have a registry for this called the pod registry. So these are all programs that Babashka can pull and then use as a library. So we have a file watcher, for example. We have some libraries around AWS. We have something around SQLite. And the benefit of pods is that they can be implemented in any language. So this pod, for example, the file watcher is implemented in Rust. And this we have another file watcher which is implemented in Go. And some other pods are implemented in Clojure itself and then compiled to GraalVM native. Just to show the pod example how it works. So this, I'll just put it here. So what happens is you load the pod and then it gets downloaded if it's not already on your system. And then you can require namespaces from this pod. And so here we have a namespace called utils, and we convert this input to HTML. So this is called hiccup, which is a data representation of HTML. And now we use a function from the pod to convert it to HTML. We actually don't need this anymore because this is now in Babashka, but you can also do it the other way around. So if you start with HTML, this, hello, and you want to parse this, then let's see, you can parse this, I think, as hiccup. Let's try this, if this works. I put it in the same script. Oh, okay. Hello. It doesn't quite work. Sorry, this is maybe not a good example. So I should probably update this example, but there are a lot of examples here. For example, if you want to interact with SQLite, for example, we have a SQLite pod here. And so you can just execute this code and it will pull this pod, and then you can interact with the SQLite library, SQLite database. So, this is pretty complex, and this is why we need another executable to provide this functionality, because we cannot interpret this code. This is what pods are about. So you can read more about all of this in the book. Let's see. So Babashka is not only a toy side project of mine. It's really used by companies as build scripts, and I'm also getting sponsoring from some of these companies to work on Babashka, which is very nice. If you want to know more about scripting in practice, how you do scripting with Babashka, you can watch this talk at the Los Angeles Clojure user group. It goes into a lot more detail if you want to know more specifics about Babashka. And I really enjoyed this talk, even though I already knew what was possible. So now we will go into more details of how Babashka is built and what components does it have and how does it work. If you don't have any other questions.
Not at the moment, so please go on.
Okay, cool. So Babashka itself consists of a couple of parts, and one part is we need to parse command line arguments, obviously, to do stuff. But it also, Babashka packages a lot of libraries, so we need to configure these libraries to work well with Babashka, and sometimes we need to apply a patch or something related to GraalVM if something doesn't work out of the box. So Babashka has a concept called a class path, which means you can load code from anywhere on the class path if you set the class path correctly. It's similar to how it works on the JVM, but I had to re-implement this because GraalVM did not allow me to use the class loader classes out of the box. And then there is something called a class config, which tells Babashka which classes it should remember into the native image, because not all of the JVM is available. So we need a giant list of classes like Java IO file system, Java Neo file path, for example, is all supported in Babashka because this is important for scripting. So we need explicitly to tell Babashka what classes are should be available. But then Babashka also has a REPL. I haven't showed this yet. So you can start, if you start Babashka, it starts a REPL by default. And well, you can interact with this the same way as Clojure. So this is all all part of this Babashka binary. But most important of all, it needs to interpret your code. And this is a separate library, which I split out at one point. And this became the small Clojure interpreter. So this is Babashka, all the parts, and then the code evaluation is done by the small Clojure interpreter. So what is the small Clojure interpreter? It's a library which works on the JVM, and it's compatible with GraalVM, but it also works in JavaScript. So you can use small Clojure interpreter also in the front end. This is useful when you have a Clojure front end, but you want still after compilation, you still want to have some way of evaluating Clojure code. It supports sandboxing, so all the code that you evaluate in this interpreter is not affecting the state of the outside world unless you provide functions that allow you to alter the state of the outside world. So it does not define global vars or global things in your environment. Everything happens in a dedicated context. So all the Clojure interpreter also works in advanced compiled apps, which is, if you're not familiar with how Clojure script front ends work, you have basically 3 modes of compilation, which is none, which means the code is just emitted and nothing happens on it, so it's readable. Then you have simple, which just appends all the files into one file. And then you have advanced, which strips away all the unused functions. This is an optimization provided by the Google Clojure with an S compiler, which is used in Clojure script. But why I'm telling this is that Clojure script also provides a self-hosted compiler, which works in the front end, but it is more heavy than this interpreter. It yields about 8 megabytes of JavaScript, and it also doesn't work with advanced compilation. So if you only need a tiny bit of interpretation, the small Clojure interpreter might be a better trade-off if you want to have a smaller bundle size. Okay, so this interpreter provides a couple of functions. One is called eval string. You just give it a string of Clojure code, and then it will evaluate it. So this example is a Clojure function, which adds 1 and 2, and then an argument. This is a short notation for a function. So when you evaluate this, you get back a function f. And so you can then evaluate this function with an argument, and then it returns the number. So this is what you can do. I will go into more details later. I already explained this in the beginning, that native image comes with this limitation, and this is why I need to have something like an interpreter to still be able to evaluate code in native images. So if you want to take a look at this interpreter in isolation, you can go to GitHub Borkdude Sci. Borkdude is my nickname on internet. And you can also see a list of other projects that are using this interpreter, because this interpreter allows you to evaluate Clojure on the command line. And this is not only useful in Babashka, but it's useful in a wider variety of command line applications. So the interpreter, this is how the interpreter is structured. So we have a main entry namespace, which is called sci.core. If you evaluate a form, you start here, you call eval string, and then it goes into these namespaces, which are not exposed as a public API, but this is how it's structured internally. So we have one namespace, it's called interpreter, and it calls the parser. So it transforms a string into S expressions, and S expression means, so if we are in Clojure, so this is a string, but you can read it, and then it becomes a structure. And if you say type, for example, then this is a list. So the string is converted to a list, and you can say, well, I want the first thing of this list, and that is the symbol plus. So that is what happens basically in the parser. It transforms text to data structures, and these data structures are called S expressions. And in Lisp, you write programs using S expressions. So the program itself is represented by data that you can also manipulate inside of the programming language. When that is done, so the parser produces data, then we go to the analyzer, and the analyzer analyzes these S expressions, and it prepares these structures to interpret these structures as efficiently as possible. So it resolves symbols to existing functions, to local variables. It detects if you have a valid local variable name, and it also detects if you use names that are not valid. So if I type here, if I type something like this, X, it doesn't mean anything. So then it says I could not resolve the symbol X, and this happens in the analyzer phase. So that is what happens over here. And we apply optimizations. For example, if we type if true 1, 2, this expression is simplified in the analyzer to just the number 1, because we can already see in the analyzer that this is always going to return the number 1. We try to do as much as work as possible in the analyzer, so we have to do as little as possible in the evaluator, because that makes functions faster. And both the analyzer and the evaluator also talk to the interop namespace, which takes care of this kind of expressions. So this is an interop, Java interop form. So it in the analyzer, it tries to resolve this to the right class. And so we know in the evaluator already which class we are calling. We don't have to look this up all the time. So this is basically how the interpreter is structured. The interop is done using reflection in the interpreter. So we are calling we are calling a library which takes care of looking up the right methods and fields and things like this. And I already mentioned the class config before. If we provide the right list of classes, then it all works automatically in the interpreter. Okay, so I will now go into the REPL for live coding to explain a little bit more details. If you have any questions so far, I can maybe explain more, but I can also explain it using live coding. If you want.
There was one question about if there is any roadmap for Babashka development, but it's not super in context.
Okay, so I can maybe comment on that at the end then. Okay. So a little bit, very quick Clojure introduction. So if you're not familiar with Clojure, so function calls are done using a list. And a list starts with a symbol, and these are the arguments. So instead of writing 10 plus 20, we write a list and then the plus sign and then the argument. So if you evaluate this, then it becomes 30. And what I'm going to do now is connect to a running REPL that I've already started. It's running here in my command line. So it's you can see it here. But it's a process that these expressions are sent to and then evaluated, and then I see the result in my editor. So this is what we commonly do in Clojure to develop programs. So now I will evaluate this form, and you can see it returns 30. This is how you define a function in Clojure. So you say defn and then the name, and then the arguments as a vector, and then this is the body of the function. So we have now defined a function foo. Now we can call the function foo with the arguments. Some Java interop. So this is how you call a constructor in Clojure. So we say string and then dot, and then the arguments to the constructor. So now I just constructed a string. This is a static method call. So I say the class and then a slash and then the static method name and wrapped in a list again because I'm executing a function more or less. So this is how you evaluate some Java. Interrupt. This is an instance method. So you start with a dot, and then you provide the this argument, let's say, and so we get the bytes from a string foo, and you can put it all together. So we are encoding some bytes to base 64, and we convert it back to a string. So this is how you do that. And another concept in Clojure is called a var. So you can say def, and then you get the name of something, which is called a var. So we bind a function to the var f here. So if we can then call the var f, it's calling the function that is attached to it. So it's an indirection mechanism. So this is the var object. You can access it by prepending this hash sign. So okay, this is a var. But the nice thing about vars is that they can be redefined. So now I'm binding something else to f, another function, and when I then call the var f again, it's bar instead of foo. So this is how we can interactively change our functions over time when we're developing. So I will skip this and then go to how Psi works. Because of time, I will choose this example of, I will show how we can create a REPL in using the interpreter. So normally I go here. Let's see. So normally I start a REPL like this, and I can interpret forms in Babashka. But I will show how this works because this goes through all of phases of parsing, analyzing, and evaluation. So we have the sign namespace, and so we need to create a context, and that means it's the world in which all these evaluated functions live. So it's remembered in this context. It's a mutable state. So if we say eval string star, it means it can take a context and it can take a string, and then it remembers the effect of evaluating this string into this context. So we define var x here in the context, and it's not a normal var in Clojure, it's a specialized var for Psi. And if we then evaluate again an expression using the same context, and we want to know the value of x, we just evaluate this and we get back 1. Okay. So now we will show. Yeah. So in my editor, I can call readline, and then it will read a line in my editor. That's just how I will read input for the REPL. So here I will evaluate the input that I will type +1, 2, 3. It's not really visible for you, but that's what I just typed. When you type in a REPL like this, it's not sufficient to read a line. So if I do this +1, 2, and I press enter, the form is not complete because I haven't closed it. So if I provide another argument and then close my parent, that is a complete form. So read line is not sufficient to parse. So I need to have a proper Clojure parser. Inside it's called a reader. So we provide the reader with the standard input. So in means the standard input in Clojure. And we create this. And now we can say to Sci, I want to parse the next form from this reader. So now it's going to parse the Clojure form from the standard input. But because you cannot see this, I have prepared this example with a couple of new lines, and this is fed into the standard in. So if I read this, I will get +1 to 3 because this string is converted to the S expression. Okay, so if we have this S expression, we can evaluate it. This is 6, obviously. But if you put this all together, so you read from standard input, you parse it, and then you evaluate it, then you get 6. Yeah? So this is sufficient already to build a REPL. So we will now make a REPL which parses the next form from standard in. Then it evaluates the form. And if it's not identical to a special value called REPL quit, then we just print something, and then we continue again with the function. We call the function recursively again. So let me try it. So I will define this function, and then I need to show the output of the REPL. Let me make this a little bit bigger. So I will now start the REPL, and it reads input. I will type +1 to 3. You cannot see this, but this is what I'm doing. And now it prints 6. And if I type REPL quit, it stops, and then the REPL returns nil. This is how that works. So this is already showing how you can write your own REPL using this interpreter, and this is basically how it's done in Babashka, but it's more sophisticated, obviously. So maybe one more example. I think I have 5 to 10 minutes, maybe a little bit more technical, maybe. So let me go into show. I mentioned that the Sci interpreter is composed of a couple of parts. So it's the parser, the analyzer, and the evaluator. So I will define a context. And it's the analyzer's job to inspect and enrich forms with instructions for the interpreter, or it's actually called evaluator now. So here we parse the string. This is just the symbol X. But if we analyze it, and the symbol X doesn't mean anything in this context, the analyzer throws an exception. So I evaluate this, and then you see, oh, it's a Sci error, and with the message could not resolve symbol X. So that happens in the analyzer. Okay, but if I parse something that is correct and I analyze that, then I get back something more interesting. So here I am defining a function. So the analyzer, well, this is just an S expression when I parse it. But when I analyze it, the analyzer gives back some data structure. Let's see, print, yeah. So I have pretty printed this. And so this is just a data structure that the evaluator needs to efficiently execute this function. And it also, so the analyzer also puts some metadata on the analyzed form, so the evaluator knows what to do with it. Let's see. But if I then feed this analyzed function into the evaluator, which has a function called eval, then it returns an evaluated interpreted function, which I bind to interpreted function here. And this function I can call from Clojure again. So if you can see it returns 1 because that's what I said here. So this is what happens in the interpreter. We start with parsing, then analyzing, and then evaluation. So that's a little bit how that works. Are there any questions about this?
So no questions about this. Some questions about the Babashka runtime limitation. Yep. So is there any limitation on memory in Babashka? Because we kind of understand how it works in JVM, what's going on in Babashka, in Graal build, and how much, and another question, how much data can I process with Babashka?
Yeah, those are good questions. So a Babashka binary, you can, I think you can measure the memory usage like this. No, I need to have another shell. Let's prompt. So like this, I think. So you can see it took 18 megabytes of memory now to execute this expression, but you can limit the memory by saying XMX. I think XMX is, I don't know, 10 megabytes? No, I don't know from the top of my head, but you can influence the maximum memory. But if I will do the same with Clojure, let's see, Clojure minus M, and you can see it takes a lot more memory. So here it takes 183, and Babashka only took 18. So yeah, that's quite a difference. So GraalVM images usually take far less memory than full-blown JVM. So that's one part of the question answer, I think. And the other answer may be how much data can you process? It depends. So yeah, I don't know. I think the JVM is usually better at large volumes of data, but yeah, I don't know. Mm-hmm. You just have to try it out, I think.
I think the question when you get some exception that no, memory is not enough.
Yeah.
And what kind of garbage collector working in GraalVM? It's some
that's
count or what how it works.
I actually don't know the answer to that question.
Have you encountered any limits of Graal in terms of resources like memory? So you start processing your big CSV and then get out of memory or something?
No, not really. No. Not really. No. But I think you can look up this information on the GraalVM website. So they have lots of information, details about this, about throughput and latency and stuff like this. So I can put this maybe in the Telegram chat so people can check this out. I don't know all these details from the top of my head, but usually I haven't run into any weird situations where I got some weird exceptions about memory that I did not get with normal Clojure. Any other questions maybe about how the interpreter works, or?
Maybe just general question. What was most challenging feature to implement?
Yeah. So yeah, that's a good question. So
Where you spend most of your time?
yeah. Well, I have to tell there are a couple of edge cases in Babashka because in normal Clojure you can do things like dev protocol foo. Foo. This is kind of like an interface in Clojure to simplify things for the audience. And but in Babashka I have to a little bit fake this because in Clojure this defines a class foo in the background, and this is something I cannot do with the GraalVM binaries. I cannot create new classes at runtime. So what I do here is I register this as some special value, and then, well, you can say def record bar, and I'm implementing this interface, well, protocol really, but I'm just calling it an interface for the audience. Oh yeah, so let's do it like this. So this is a record with a field X, and when you call the foo function on it, which is from this interface, I will just give back X. Okay? And when I then make a record, R1, so this is the record, but when I call foo on it, it returns 1. And this all is a little bit faked because on the JVM, this is a real class. And this is also an interface class. But in Babashka, those are values that are more or less fake. They try to work the same, but I had to make up workarounds for this to make all of this work correctly. I think that was one of the most challenging things. And there are some limitations, like we don't have def type in Babashka, because def type is pretty much the lowest level thing that you can have in Clojure. And this is not so easy to do, yeah, to fake your way around this, let's say. So this is something I do not have there.
Yep. And you probably encountered some limitation of GraalVM and some Java libraries, as I know GDBC doesn't work with GraalVM. Yes, can you say what?
Yeah.
What
So yeah, actually, JDBC does work with GraalVM, but you have to usually provide some configurations. So I have a project which is called SQL Pods, and this allows you to speak to databases from Babashka. And one of them is Postgres, for example. So you can say load pod Postgres, and so this is the project which provides that pod, but you have to give GraalVM some configuration to make it work. So for example, here we provide a class called PG connection, and so GraalVM cannot statically analyze that PG connection has a method called close, or that it's being needed in the image. So we have to help GraalVM a little bit by providing these configurations. So I have Postgres was actually pretty simple to make it work. And all of these libraries also bundle the next JDBC library. So here we see an example. We say this is connection data, And here we execute against this database this query, and then you get back some other data. And this is all done using the Next.jdbc library in the background. Postgres was relatively simple to configure, but if you look at, let's see, Oracle, for example. Oh, actually, there is nothing. Or this one was more challenging to find out what kind of things we needed to help GraalVM with. So, but all these tests for all these databases are all passing for different operating systems as well. So maybe if you have any questions about how to make Postgres libraries work with GraalVM, you can take a look at this project. But there is also another nice project called PGMig, which is a Postgres migration runner. And it's based on Migratus. You may notice it. You may know it. Sorry, it's a Clojure library to run migrations against a database. But this one focuses on running these migrations against Postgres from the command line. So it's also GraalVM binary. It's very fast. And it also uses Psi for interpretation of functions, because this Migratus library, it also allows you to run functions during the migrations, and this is also done using the interpreter.
Thank you. There are some official places when people, like for Java and Clojure libraries, putting these configuration files also. Or you always have to investigate and find which classes.
Yeah, I know that for HTTPKit, for example, this is a web server which is built also into Babashka. There is some documentation in the README. Let's see. So here it says, well, native image, if you want to use this reflection, and also use this flag. So yeah, it depends on the library if they provide this kind of information or not. But there is also a repository called Clojure. I think it's called let's see, Clojure Graal, or what's the name? Yeah, GraalVM Closure. Oh, here it is. And this contains a lot of information about which libraries work with GraalVM and what kind of configuration you need. So they provide also examples just to demonstrate how to use it and what kind of configuration. So I think this is useful. And there is another project called CLJ GraalDocs, which provides a lot of tips and tricks for GraalVM. So that might also be nice to look at.
Do we have similar Java resources for Java libraries? Because we are using a lot of Java libraries in Clojure code. But
yeah, I actually don't know. Maybe this project also lists Java libraries, but I'm not sure. But what I also do sometimes is look at, there is a project called, I think it's called Helidon from Oracle. And they have a lot of extensions that are basically Java libraries with some GraalVM tweaks. Don't know if I remember this correctly, or it was maybe the one from Red Hat, but maybe the other project. But there are some of these Java frameworks which are optimized for GraalVM, and then they do a lot of work to make these libraries that they are supporting to work with GraalVM. So I usually visit one of these frameworks to see how they do it.
Okay, cool. Thank you so much for this. I have to admit that it's really impressive. Some parts of it really went over my head, especially the Clojure interpreter written in Clojure. It was difficult. I think I will have to revisit it at some point. But really, thanks. It was awesome. I'm really looking forward to trying Babashka for some scripting. It would be cool. And with that said, I invite Michiel and Nikolai and all the audience to the discussion zone in Zoom. The audience can use the link to click it, and you will get separate links to it. Thank you again so much.
My pleasure.
Thank you.